Hey 11s, here we are with another video. Intercepts and the sign of a function. Let's talk about the sign of a function first. By this I don't mean the value, although something a little bit like that. I'm interested in, at some value of x, is the function positive or negative? How do I determine that? Well, I could have a look at a graph, which is really what we did. Come back up here, it's really what we did here. I say that this function is positive when x is greater than 3 or x is less than negative 2. It's negative between x is negative 2 and 3. Okay, you can see the sign. These parts here are positive, positive, negative. Yep. So, find this, we're going to substitute in. So, what is the sign of this? Some function equals this. Well, I want to know when x equals 2, so instead of x, I write 2. Function, not of x, function of 2 equals 3 by 2 cubed minus 2 by x squared minus 1 equals 3 by 8 minus 8 minus 1 equals 15, I reckon. So therefore, function x is positive, it's a positive number, is positive at x equals 2. We'll use that technique for some other things later on. Now, this, just a bit of a byline, this sort of an expression here, or an equation, or even a function, it's called a polynomial because I have some x's in there, and they have integer powers, right? They are positive whole numbers, positive integer powers, positive whole numbers. I don't want any square roots. I don't want any, I don't want x in the bottom of any fractions, and I also don't want x in any of the powers. Okay, they're polynomials. They will all have a domain of all real x. Now, the range is sometimes restricted. The range is sometimes restricted, particularly if that highest power is an even number. These are called polynomials, and we'll be dealing with those a lot in this topic here. Right, they're nice straightforward things. One of the good things about polynomials is that they are continuous functions. Right? I can trace my pen along the curve, and I don't need to pick it up and get back to it somewhere else. There's no gaps or breaks in that. Right? Think of the different functions that you've drawn, right, that you can recognize now. Some of them follow that, some of them are continuous, things like straight lines and parabolas and cubics and other things like that. Think hard, something that's not continuous? Well, for one, a rectangular hyperbola. Remember, we've got sort of two parts of that. Right, and I can't draw the whole lot without lifting my pen up. Okay. But those, where I can, are called continuous functions. Now, we are looking to sketch all sorts of things here. And when we are sketching graphs, one of the most important things we've got to find are the intercepts. Sometimes these are called zeros because that's how we find them. We let something equal 0. Also, the x-intercepts are commonly called the roots of an equation. So, you can see there's a slight mistake here in my notes. I've jumped the gun a little bit, but anyway. To find the y-intercept, substitute x equals 0. X-intercept, y equals 0. Right, think about that in a number plane. What does that mean? Right, the y-intercept is where it crosses the vertical axis. Right, that's where x equals 0. It's where I haven't left that the origin side by side. So, we work it like this. Right, we say, let x equal 0. Therefore, y equals 0 squared plus 5 by 0. I wouldn't normally write this line, but it's the first time. Plus 6. Y equals 6. So I have a y-intercept at, my y-intercept is 6. Right, when x equals 0, y equals 6. It's going to cross the y-axis at 6. Now, let y equal 0, and it normally gets a little bit more complicated here. Right, that part's usually very easy. The y-intercept. The x-intercept, often there's more than one, and it's not so easy. So, now I say x squared plus 5x plus 6 equals 0. Right, I'll need to factorize that, and I get x plus 2, x plus 3 equals 0. So x equals negative 2, and, I don't know, x equals negative 3. Okay, they're my two x-intercepts here. I have two x-intercepts and a y-intercept. Okay, wonderful. Let's try the same thing over here with this function. Now, this curious looking thing, it's been factorized. That's going to help us out. It's not going to be quite so helpful when I find the y-intercept, but that's not going to be so difficult. So remember, to find the y-intercept, I let x equal 0. Therefore, the function of 0 equals 0 times 0 minus 3 times 4 minus 5, lots of 0. Well, you know what? Doesn't matter what I have over here because 0 times anything equals 0. Okay, so this function here is going to pass through the origin. When x equals 0, the function of x, or y if we graph it, equals 0. Remember, function x, y, generally the same thing. So, there's one of them. The other thing we've got to do is to find the... That shouldn't be function 0. That should be function x. Function x equals 0 when function x equals 0 when x equals 0. Now we want to find function 0. Now we're going to say it. Never mind, I started to ramble there. Now we're going to let function of x equals 0. Okay, we're going to see what happens. It's like y equals 0. Let function x equals 0. Therefore, I have x outside of x minus 3 outside of 4 minus 5x equals 0. Now our null factor theorem tells us that, instead of being two things, now I have 3 factors multiplied together. If I have 3 factors multiplied together equal to 0, if any one of those equals to, well, one of them must be equal to 0. At least one of them must be 0. So we know that x equals 0 or x minus 3 equals 0 or 4 minus 5x equals 0. Okay, because I've got 3 x's multiplied together here, because this is a cubic, I can have up to 3 roots here. Now we've got one of them, x equals 0, and we already knew that, I suppose, because that's the y-intercept as well. Now, if x minus 3 equals 0, then we know that x equals 3. Okay, add 3 to both sides. Now over here, a little bit more complicated. I know that minus 5x, negative 5x, equals negative 4. So x is equal to 4/5. Okay, so there's my 3 roots. X equals 0, x equals 3, and x equals 4/5. And my y-intercept, my vertical intercept, is at the origin, is at 0. Okay, that's how we find the intercepts of a function. Good thing to be able to do. I will put the rest of this in the next video. Keep an eye out.